here we don't have a logarithm, but we have a fraction. And the fraction is 4 over x plus 2. But what do we know about fractions? We know that fractions, in terms of fractions, if the denominator is 0, the answer is going to be undefined. And if the numerator is 0, the answer is going to be 0. So here we are looking at our denominator. And we know that if this denominator is 0, which means that f of x is going to be undefined, hence the value of x when the denominator is 0 is not part of the domain. So how do we find this our domain? We take whatever is on the denominator and equate it to 0 to see what is the value of x that causes 0 on the denominator. So here we're going to be having x being equal to negative 2 if we solve the equation. Now, since x is negative 2, this is the value that causes this f of x to be undefined, which means that this value is the value that we do not want in our domain. All the other values you may take, but not negative 2. So what is going to be your domain in this case? Your domain in this case is going to be x is not equal to negative 2, and x is an element of real numbers. So ladies and gentlemen, I hope you know how to find the domain. These are just the steps. We're going to be having more videos later. Not only are you told to find the domain, sometimes you are told to find the range. So here is an example of a function. F of x is equal to x squared plus 4. And what do we know about this graph? This function is a function that takes all the real values. So the domain in this case is going to be just x is an element of all the real values. All the real values are defined, give defined outputs, or when we put them into the function f. Now here, I want you to think about this. What constitutes our function? This our function consists of an unknown part, which is x squared, and 4 added to the unknown part. And we know for a fact that even when we take the largest negative number and raise it to the power of 2, it is always going to give us a positive value. There is no way for real values to be raised to the power of 2 and become negative. X squared has no negative values for real values of x. The minimum value for x squared is when x is equal to 0, and 0 squared is going to become 0. So the minimum possible value that we are going to get out of f of x, the minimum possible value is the value 4 when x is 0. Are we together? So here, the range is going to be f of x is greater than or equal to, which means that whatever that we are going to be getting out of this function is never going to be less than 4. Why? Because 4 is the minimum value, and we proved it when we saw the nature of this of the function itself. Another way to think about this would be plotting a graph. If we were to plot the graph of y against x, here, plotting the graph of y against x, the graph would turn at 4. Here we have the graph of f of x is equal to x squared plus 4. Now, this graph, you look at this graph, you're going to see that no part of the graph gets below the line y is equal to 4. No part of that graph gets below y is equal to 4. Having a look at this, you're going to see that this graph, whatever the values that we output here, are always going to be greater than 4. Therefore, from this graph again, you can deduce that f of x is always greater than or equal to 4 when we are at our minimum point. So there are two ways of going about it. One is to just start the function. The other one is to just plot the graph whenever you want to find the inverse, or whenever you want to find the range of a function. So here we have a function. And the first step to finding the inverse of this function is to make everything simpler. You first substitute whatever this is with a simple unknown letter, y. Now, having this letter, we are going to equate it to what? To 3e to the power of 2x plus 1. Now, according to the law, we know that the input, which is x in this case, the output is y, and this is for the function. But for the inverse, the output of the inverse takes the place of the input. Why? Because we know for sure that the domain of the inverse is the range of the function, which means that this x here is supposed to be where there is a y, and the y is supposed to be where there is an x, because the input and output, the input of the function, because the input of the function is the output of the inverse. So here we have x is equal to 3e to the power of 2y plus 1. You interchange the two, y that I just said talked about. Now here we have x is equal to 3e to the power of 2y plus 1. So we are going to, now the next step here is to make this the subject of the formula. So here we are going to divide by 3. If we divide everything by 3, we're going to get 1 over 3x is equal to e to the power of 2y plus 1. Now, having this, we are now supposed to find a way that can let us extract this y. Now, y is the power, 2y plus 1 is the power, and the base is e. This is an exponent, right? Having this exponential function, to just simplify everything that we have, we introduce the natural logarithm. So here we have ln of 1 over 3x is going to be equal to the natural logarithm of e to the power of 2y plus 1. So after this, we are going to be having what are we going to be having? We're going to be having natural logarithm of x over 3 equal to 2y plus 1 multiplied by the natural logarithm of e. And we know that the natural logarithm of e is 1. So what are we going to do? We are just going to substitute 1 for the natural logarithm of e, and here we're going to be having the natural logarithm of x over 3 is equal to 2y plus 1. Take 1 to the other side, it's going to be negative, so we're going to be having the natural logarithm of x over 3 minus 1 is equal to 2y. And what is our y? Y is going to be equal to half. Half what? Half the natural logarithm of x over 3 minus 1, which is the same as half natural logarithm of x over 3 minus half if we expand whatever we have. So this is going to be the inverse. Why? Because it's the output of the other function. It is the output of a function that is such that the input to another is the output of this particular function. This is how you find your inverse. Now let's look at another simpler example, and we want to find the inverse of this particular problem here. So what are we going to be having? We have f of x is equal to 3x plus 4, and you want to find the inverse. Here we're going to be having, if we first recall the process is the same. Y is equal to 3x plus 4, and since the domain of the function is the range of the inverse, we interchange the positions of x and y. Why? Because we should interchange the input and output. So we're going to be having x is equal to 3 multiplied by y plus 4, and then after this we are going to make y the subject of the formula, and after that we are done. Now here we take 4 to the other side, it becomes negative 4, so x minus 4 is equal to 3y, and after that we are going to divide everything by 3. After dividing everything by 3, we have x minus 4 all over 3 as your y. This is going to be your inverse. So finally, f inverse of x is equal to x minus 4 all over 3. If you are to try it out, just find a domain, put the inputs into the function, and put the outputs of your function into the inverse. You're going to get the inputs that you had put into the original function before.
So good day, ladies and gentlemen. If this video was helpful, press subscribe, share, click on the notification bell so you will be notified whenever I post a new video, and put a comment down below, as this would help me make new videos. Remember, keep learning, because those who stop learning stop living. See you in the next video.